Welcome back. This is the VM encryption lesson. In this lesson, we're going to cover the following objectives. We should be able to meet these following objectives: being able to describe the components of a VM encryption architecture, manage encrypted VMs, encrypt core dumps, use encryption with instant clones, migrate encrypted VMs, list VM encryption events and alarms, and enable encryption or encrypted vSphere vMotion. A lot of really interesting topics here in this lesson. Notably, we are talking about VM encryption. So let's take a look at the key functions of VM encryption. First thing, let's just take a look at what is VM encryption trying to solve. So in a large environment, you'll have a whole variety of administrators. And so you've got storage admins, you've got vSphere admins, and they'll all have access. Well, the administrators of vSphere will have full admin privileges to the vSphere client. And they'll have access to what we call the data store browser. You may remember we talked about that back when we were talking about vSphere security general best practices. You generally want to lock down that data store browser, the files tab. Whenever you click on, say, an ESXi host and click on its storage, there's a files tab, or you click on a data store and there's a files tab. That's the data store browser. And if anybody has access to that data store browser, they can simply download any virtual machine, download their virtual disk, and walk away with it. So that's what we're trying to prevent, that type of simple, just walking away with important corporate information, right? So sure, we need to trust all of our administrators. We certainly want to limit who has access to that data store browser. And a traditional vSphere admin does have access to that. So this is essentially going to encrypt everything related to that virtual machine, all of their files. Every file in that VM folder will be encrypted, including, of course, virtual disks. So that means if somebody were to attempt to download the virtual disk and, say, walk away with it, the only way they're going to be able to get access to that data is if they had access to the key that was used to encrypt it. And guess what? VM encryption actually uses a multi-layer key of encryption. So you need access to two keys to get access to that data. And one of those keys is never stored persistently in vSphere. So a very challenging process here. So let's take a look at some of these key functions, understanding the premise of what is VM encryption. It's essentially encrypting your data at rest, but at the same time, it's actually encrypting all this inside the ESX server before it leaves the host and hits the storage network. So it's also going to have in-flight data protection as well as data at rest protection. So like we just mentioned, the function of encryption, we're protecting our virtual machine disks and the metadata files. So we're encrypting the entire VM home folder, including the NVRAM and the vSwap file, everything, all right, with this multi-layer key protection. Essentially what this means is that when you decide to encrypt a VM, what will happen is the ESX server the VM is running on will actually generate a key to encrypt all the VM data, right? So now you've got a key that's got the protection of the data. Then another key will need to be generated not by the ESX server, but instead by a separate third-party key server. So now you have a key generated from the key server that is sent down to the ESXi host, and that key will encrypt the key that was used to encrypt the data. So essentially we have these two classes of keys. We have one key generated by the ESXi host that encrypts the data. That's called the data encrypting key. And then the key that comes from the key server is there to encrypt the data encrypting key. That's called the key encrypting key. So again, two kinds of keys. The data encrypting key generated by the host encrypts your data, and then the key encrypting key that comes from the KMS, the key management server, will encrypt your data encrypting key. And so it's as if you had a safe that you put valuables in it and you lock that safe with a key, and then you take that key and put it into another safe, which that safe is locked with yet another key. So there's the data key that protects your data, and then the key encrypting key that is encrypting the data, encrypting key. So the other important detail here is the key that comes from this key server is never stored anywhere in the ESXi host. Instead, it's actually held in a secure key cache area of ESX server memory. So never stored on disk anywhere. That key encrypting key is only ever stored securely in your key management server system. So you've got security on the top level key encrypting key, and then that encrypts your data encrypting key, which is then encrypted. The encrypted data encrypting key is actually stored in the VMX file with your VM files, which is good because now that home folder for the VM is typically held in shared storage. So what if I were to migrate that VM to another host, right? You've got a DRS cluster. We want to be able to have the VM move from host to host. Well, that data encrypting key is held with the VM in its shared storage. So all the ESX servers should have access to the data encrypting key, but we need to be able to get to that key by decrypting it. So the key server who sends the key encrypting key to the host will actually send it to all the hosts in the DRS cluster. So all the hosts have access to the same key. In fact, every VM will get their own key encrypting key. So you have 100 VMs, the KMS, the key server, will generate 100 different key encrypting keys. You can almost call that the VM key because that's what the key encrypting key is. It's one key per VM generated by the KMS, stored in the KMS, but sent down to the ESXi host so that the host, and it will send it to all the hosts in a cluster, so that every host in the cluster has the ability to encrypt and decrypt the data encrypting keys, which are then held on shared storage. This creates a very, very strong level of encryption so that, again, the only way anybody would be able to decrypt this data is that they need access to both the data encrypting key and the key encrypting key, which are then stored in completely different locations. Now, that sounds like a lot. What also is useful here is that the deployment method has been simplified. It's simply all part of the vSphere storage policies. It's yet another one of the filters as part of the VAIO filtering capabilities that you have with data services. This is essentially where all the disk I/O comes out of the virtual machine will be intercepted by this filter. Once you enable the storage policy for encryption, the host will intercept the VM's I/O, will encrypt it, and then send it out to your storage network already encrypted. That means I don't need anything special in the VM's guest or anything in storage. So it's guest OS agnostic. No agents are needed in the guest OS. And it's storage agnostic. You could place the encrypted VM in any supported storage. As we mentioned, the key management is handled by an external third-party key server. There's a list of certified servers, one by Dell EMC, one by IBM, another one by HITRUST, and a couple others. It uses the key management interoperability protocol. It must be using KMIP, which is the industry standard for key information exchange. And again, the keys are not stored anywhere in vSphere persistently. The keys are only stored inside that key server. There's also access controls where the principle of least privilege is applied. You can define a small set of administrators who have access to the encryption capabilities, and then you have the majority of administrators who can do everything except for encrypted tasks. So you have the vSphere administrator, which has full access, and then you have this additional role called the no cryptographic administrator, or as we usually say, the no crypto admin. This is a general administrator who can perform almost all tasks in vSphere with the exception of anything having to do with encryption. So you can ensure only those authorized to do encryption are granted that access, and then the general administrator staff have access to do everything except for encryption. So encryption's been around for some time. It was introduced in vSphere 6.5, some enhancements were made in 6.7, and then now some other new features were added in vSphere 7. So it's got a lot of cool maturity capabilities. As we mentioned, the virtual machine's disks are all encrypted and can be only accessed with a digital key, in fact with a multi-key layers. And the vSphere access control restricts access to that digital key for decryption. As we mentioned, you've got to have one key from the key server and another key that is generated by the host where the VM was first encrypted. And the data is encrypted in flight. vSphere 7 introduced a few additional nice features. For instance, there are now VM operations that support encrypted VMs that we didn't support in the past. New feature that HA is supported. We used to just support DRS in terms of how the keys get distributed throughout the cluster. So now when you enable a DRS HA cluster, or just an HA cluster, the keys will be distributed to all the hosts, which is important. If a VM fails over to a new host, the new host has to be able to decrypt that VM over there. There's new APIs to improve the management of the VM encryption environment, and new events and alarms can be used to monitor the VM encryption environment. Also, some advantages we've talked about already. We do not need any in-guest agents. Like we said, this is actually done outside of the guest OS. This is all handled in the VM kernel as the I/O leaves the VM intercepted by the VM kernel as one of the filters as you enable the VM encryption policy, and then it leaves the host already encrypted, so it doesn't matter what underlying storage you have. It supports both any guest as well as any storage. It's a uniform methodology across all guest operating systems, therefore. It also protects all your VM data, including swap files, not only those virtual disk files. You can, in fact, have granular key control if you like. You can have a different key created for each of your VM's virtual disks. Generally, that's more than you need. You can simply create one key or let the KMS create one key for the whole VM if is a standard practice. It also offers easy orchestration through storage policies. Like we mentioned, you simply enable the encryption policy on the VM or VMs that you need to have encryption on. You don't need to set this on every single VM. You set encryption with a storage policy on those VMs who have this critical need to keep their data private. As we mentioned, it's compatible with the KMIP protocol, the industry standard language for the management of security keys. It allows interoperable exchange of data between different key management servers and clients. So bringing it back full circle here, right? The business case. We've actually already mentioned all this, but essentially, what are we trying to do? We're trying to solve this problem of a large company who has several vSphere storage admins. The company must protect its confidential data, and we need to essentially prevent a rogue administrator from being able to download a virtual machine and its virtual disks and essentially download it from the data store browser and walking away with it. VM encryption simply allows the company to secure those VMs that have to have that confidential data, and it is therefore impossible for somebody to gain access to the data without those keys, right? Both the data encrypting key that the host created and the key encrypting key that the key server created. So that key is not readable in any file. It is secured by an extra layer of encryption, as we mentioned, because of the fact that one key actually encrypts the other key, and the key encrypting key is never stored in vSphere persistently. So it's also critical to keep those key servers in a cluster also protected, as they normally would be for any kind of key server management system. And of course, we only grant limited access for the select administrators who have the need to encrypt and decrypt VMs. So that was the introduction. Let's take a look at the actual interoperability and other components after we take a quick break. So we'll see you in a few minutes.